Thank you everyone for joining us today. We'll be speaking about our journey to the cloud. My name is Kurt Azzopardi. I've been working with Novibet for the past 4 years, and I was initially recruited to investigate a cloud option for Novibet.
Hello everyone, my name is David. I'm the DevOps architect for Novibet, and I was basically recruited to do what Kurt was doing as well, and to make sure he didn't go insane doing it alone.
Okay, so who is Novibet? So Novibet is a game tech company. We are based in Athens and in Malta. Our tech hub is based in these two countries. And we offer online casino, sportsbook, and as well poker. We also build our own platform internally, which we are very proud of. And we are live in around 11 countries, where our biggest market is Greece and also Brazil, and then the rest of the world. So, segueing into our presentation. So, around 2020, Novibet started to experience rapid growth. And we had to face a few challenges with our scaling, traffic, the usual issues you face when you have unprecedented traffic. So, as well, back then we were 4 people inside the team, myself and David, with another 2 junior DevOps engineers, and we started to tackle these problems. Now, mainly, we were still based in Malta, and the data center back then was in a managed service contract, so it was very like a reactive approach when we needed something new, and we started to feel like we are outgrowing this kind of working model for us. And this will segue into our 3 main issues we started to face, leading the first thing with traffic.
So, traffic. We're all familiar with it, right? Both at work and outside of work. I mean, if you can see outside, traffic everywhere. So, what traffic problems we had? Basically, it was the biggest pressing concerns we had in our smaller managed data center was the limitation of resources and how much resources we could request. The biggest one of that would be the uplink limitations, meaning bandwidth limitations, how much we can burst, and how much of that we can sustain. We were also very, very susceptible to a hug of that, meaning when an influx of legitimate traffic brings you to your knees, literally ensuring that no other legitimate customers, can access your site. It's basically a self-inflicted DDoS by your clients. So, to request resources to mitigate this stuff, it was a bit of a pain. So we'll elaborate a little bit on how we try to mitigate these issues. Of course, to try and mitigate the sudden bursts of traffic, given the nature of our operation being sportsbook and casino, we're at the mercy of sporting events and any promotions that our marketing teams do. So we needed a way to be able to burst and sustain those bursts. The first and most obvious solution in this case was to introduce a CDN edge cache. As a CDN, we use Cloudflare. We started off with the very basics, with the most immediate and pressing concerns. Those would be static asset caching. I mean, it's the easiest, right? It's what everyone should be doing nowadays. Then we moved later on onto more complicated layers of caching. So by that, I mean JSON caching, dynamic API caches. We're also introducing now stuff that is varied across different channels and devices. So yeah, that was the most important improvement we could do at that time to make sure we alleviate our bandwidth problems. We also introduced a very similar concept to what we did on the edge. We introduced something internally. Given that we can't make use of Cloudflare caching internally, we opted to do something very, very similar, but we used Nginx instead. Speaking of Nginx, we're still heavy users of Nginx nowadays, not just for caching. We were also at the same time working and investigating our cloud migration, where we were and still are heavy Nginx users, and we tried to adopt some of that technology that we invested in and we learned to our current problem. So this came with a way of templating Nginx configuration that is tailor-made for Novibet. It's basically written in-house. It's something that we still, as I said, use to this day. And we also made, because of that, we made several internal layer 7 routing improvements. Rather than relying on the technology offered to us by our managed data center, we made sure to take some of that onto our own responsibility, and by doing that, we were able to make it a little bit more dynamic and streamlined. And now, an actual real photo of me or Kurt during one of our weekend hectic incidents.
So we're moving now to scaling. So as David is mentioning, after we implemented all those amazing solutions to just alleviate some of our traffic, they just gave us enough breathing room to start investigating scaling as a whole. So as I mentioned previously, we had issues with requesting resources from a small data center. So first we started requesting a server because that was our use case. And the way that worked is we asked with a normal Jira ticket, for example, with the provider, they reply to us, we had SLA, so for example, one server could take us up to 2 days until we received it. And then one server became 10, and the lead time increased, and then 10 servers became 20, and then there was hardware procuring that had to be involved, and this is where initially our investigation for a cloud migration became a necessity. So having mentioned all of these things with our cloud provider that, with our data center provider that inside the cloud we take for granted, like for example, you could just do something to the API of a cloud provider and you get new VMs, you get new firewalls, load balancers. So that was a big issue to us. The second part is keeping our infrastructure in line. So it's one thing to request a lot of resources, it's another to make sure that all of your resources are updated, any patches that you have on your application is being deployed accordingly. You don't forget to do one of those servers, which we did. So keeping our infrastructure in line was another thing because a growing infrastructure becomes much harder to manage with a small team. And lastly is geographical locations. So as we mentioned, we are based in Greece and we have presence in Latin America. We have more places around the world. So we needed to put these devices closer to the client to improve performance. So how do we tackle these? So first and foremost is the Azure cloud migration. So to elaborate further on this, this was around 6 months of serious planning. We had to rethink everything, some things that you take for granted that a managed service provider does for you. Again, load balancers, firewalls, you have to rethink all of that. You need to make sure that you are able to support multiple locations at the same time because a migration is not always lifting and shifting everything together all at once. So in the case of our migration, we migrated critical components, which make most of our platform. And at the same time, we left some back offices, for example, in the data center in Malta, and we needed both of them to be active at the same time. So that was a networking challenge, which we tackled myself and David. And having said all of that, with the help of Azure, we can now burst to how many things we might need. Together with that, again, it's one thing to use a cloud provider, but it's another to just to keep everything in line, like we said. So the first thing we did, we just make sure that we use infrastructure as code. I'm sure most of you are probably familiar with the concept. So we use a tool called Terraform. So what you do in Terraform is you define all of your infrastructure in code. And with the help of that, it just made the migration a bit easier to keep everything in line, like we said. So anything that we would like to roll out on the old infrastructure, it's a simple git commit, make sure you review it, and you just deploy it right there. And with all of this, it came for global distribution. So again, with a cloud provider, you can just say, I want servers in West Europe, I want servers in North Europe. It just becomes that much easier. And also, you just need to make sure that all of your networking is set up properly, again, with the help of infrastructure as code. So with all of these mainly 3 things put together, we managed to move to this Azure cloud migration in around 5 hours on the day, which was quite commendable since we had to move such a large platform. And also, we were still getting hit with a lot of traffic. Now moving on to observability.
And we start off with a photo of my home office. So, observability. Now we're in Azure Cloud, all is well and good. We're not suffering more from traffic, which we can't request immediate resources for. So now, where do we progress with this? Observability. Now, we need a way to see how our platform is behaving, right? At the moment, even though we're in Azure, not at the moment, I mean at the moment of the migration, we're still heavily dependent on the very basic metrics you get from your Windows Task Manager, Windows Resource Monitor, your Linux top, htop, iftop, the very basics. We had zero history of these, so the obvious and immediate need was to create some sort of historical data tracking with metrics. We did evaluate a couple of systems, but we settled on the obvious, so the Prometheus stack for gathering and scraping metrics, and Grafana to visualize all of this. Now, before I continue on this, I want to stress the way that we were doing problem solving. This was very, very reactive back in the day. Without these tools, without any sort of insight in your platform, you will be very reactive. You will get calls that something is not working, you don't know it's not working, and you're made aware through this call from the people reporting the problem that it's not working. That's not a good way to go about IT and infrastructure in general. So, what other problems we encountered? Of course, apart from the reactive problem solving, sometimes while investigating possible solutions, we would also stumble across a lack, so to speak, of product that might be used through in our platform. So we started finding gaps into stuff that we would need to implement ourselves. So how did we solve many of these? As I already mentioned, we made use of Prometheus and Grafana. We started off manually configuring Prometheus, which very, very quickly was clear that this is not the way to go. Mistakes happen when human errors happen. So we started looking for ways to automate this stuff. The very easy stuff was to install the exporters. We use Telegraph on Windows, and we use Node Exporter for Linux. Of course, the obvious choice here was to use Ansible. So we use Terraform to create our infrastructure, then we use Ansible to configure it. Now, what benefits did Prometheus give us that we were not kind of really looking forward, not really looking to, but that came out of the box with it? Alerting. Now we had the possibility of creating alerts about anything and any and all metrics that we collect from our infrastructure. We do this via a GitOps style of approach. We have all the alerts in a Git repository. We encourage our developers to come up with PRs for the alerting system, and it's open and transparent to everyone. Each and every team gets their and only their alerts, so we reduce clutter and we reduce noise. We make sure our teams focus on what really is important for them to focus on. Having said that, though, we also send these alerts into other kind of more general channels. By channels, I mean Slack channels, right? These are Slack notifications, where our operational and 24/7 teams can then look at these alerts for the platform as a whole. Apart from Prometheus and Grafana that we've talked about a bit now, we also introduced the Elastic Slack, the Elk stack. Basically, we generate tons of logs, and before the advent of the Elk stack inside our company, we used to have many separate sources of information. We used to literally go into servers and tail log files or open log files in Notepad on Windows. We also had Graylog. It was mostly a hit and miss, and we all consolidated these logs into structured documents, structured logs inside the Elk stack. And maybe a little mention here about the custom tooling we created also. So basically to mitigate manually configuring Prometheus, we kind of took inspiration from what Kubernetes was doing. I mean, this Kubernetes is huge. They have to be doing something right. So we imitated what they do for service discovery through the Prom agent and Prometheus operator itself, and we implemented our own service discovery, which would pick up metrics from our application servers, and it's all auto-discoverable, basically.
Moving on observability as well, what we've done inside of Novibet is we created a specific team that it wasn't present before. As you can see from the graphs David was mentioning, that is Grafana with Prometheus scraping our metrics. Previously, observability was more of a DevOps thing that we took care of. Now, with the help of this NOC team, we help them upskill themselves, and we also migrated this sort of responsibility from us to them, since they will monitor the infrastructure on a 24/7 basis, and everything becomes more proactive rather than reactive. So our current state. So we just discussed that we had issues with traffic, which David explained very well that we solved. We had issues with scaling and issues with observability. So now that all of those three are in place and we're happy with that, we move on to where we are right now after those implementations. So our platform is made of more than 300 microservices. We have a 4 nines uptime, which currently half of those services are being migrated to Kubernetes, and we did some additional fixes, which we managed to increase the uptime to 5 nines. Player increased by 3 times as much, so we started very small and we tripled our player base. And also, we're very happy to say that we managed to grow our team by an additional 10 people. We managed to grow our team by additional 10 people.
Now, let's move on to some numbers, because everyone loves numbers, right? So, what was our state in 2020 during the pandemic? So, we were already at our very, very limit back then, right? So, we would do like 2.1 billion requests monthly, which equate into something like 35.59 terabytes. To note that most of this data was served directly by our origin, because this preceded our introduction of CDN Cloudflare as a caching layer. How do we do nowadays? I can happily say that we do these numbers month on month without no problems, but very little problems. So now we've grown to 16.25 billion requests per month, which equate to a whopping 231.21 terabytes, and more than half of those terabytes are served from our CDN cache rather than our origin. Daily logs generated. So through all our platform, we have a daily log generation rate of 1.33 billion records. These are all our platform applications, some front-end stuff, and we also pull some logs from off-the-shelf systems like Redis, Kafka, and the usual stuff. Here is a quick glimpse of the technology stack we operate. So Novibet being a .NET shop, we of course make heavy use of the Visual Studio stack, both Visual Studio Enterprise and Visual Studio Code. We also use GitHub and other big names. What's notable here is the mention for the observability stack, which we spoke about earlier, which is Prometheus, Grafana, and as you can very well see there, the very, very quick introduction of Tempo and OpenTelemetry. This is something that is of a very hot topic at the moment in our tech department, and we of course see this as the evolution, the next step of our observability stack. Other than that, we of course mentioned already, we operate on Azure, so we're heavy users of the Azure compute space, and we're also making use of AKS as our Kubernetes service, which we're doing quite good, and its pace is moving very fast with adoption on AKS. As Kurt already mentioned before, with Terraform as code, with infrastructure as code, we're also capable of driving our infrastructure, be it Azure or VMware, through introductions of abstraction layers inside of our infrastructure as code. We have some development environments on VMware as well. Other than that, we use most of the big names that you guys are all familiar with. Nginx we mentioned. We use traffic as an ingress controller in Kubernetes. And we also make use of other stuff like Kafka, Consul, and Vault by HashiCorp and RabbitMQ.
Yeah, and a good point on this is our infrastructure as code stack. So as we mentioned, we base heavily around infrastructure as code. So if it is Cloudflare, we use infrastructure as code inside of Terraform providers. Any tool of choice that we use that has a Terraform provider, we heavily rely on it. And we built a custom system around this just to make sure everything is always in place with the drift detection, as well with the help of Spacelift, which is like a CI/CD platform that slots in very nicely with Terraform. Moving on to lessons learned. So we did all of these nice things, and these are like our 3 main takeaways for it. So first of all is change fatigue. So most of you here are probably developers. You have your annoying DevOps teams or infrastructure teams asking for changes every other week or every sprint.
We mean well.
But we always mean well. But something to always keep in mind is change fatigue. So when you're requesting changes, you need to pace it. You need to first have your dev teams on board, and they need to understand what you're doing. Because for them to adopt these things, it will be easier after they understand, right? It only makes sense. The other point is you can never future-proof everything. Believe me, we tried.
A lot.
A lot. We are changing things constantly. We try to make sure that we future-proof it enough, but not to the point where in the current working system we have, it becomes cumbersome. So we're saying, like, for example, things like naming conventions. They are bound to change. It depends what your company is, what your company's direction is. And also the most important part that we make sure we look at every single day is abstraction layers. So what we mean by abstraction layers are, for example, again, in our infrastructure as code, we make sure to add a lot of these local variables, for example, inside of our code. Because that means if the provider changes or something in your data changes, you just have to maintain that piece of abstraction layer. So all of your logic will be there. So whatever changes are coming, again, from upstream or downstream, just handle it there. And we can speak from experience. It has saved us tremendously on multiple occasions.
Thanks, everyone, for spending the last 20 or 25 minutes listening to us blab.
Indeed.
Thank you, guys. Thank you. So, thank you for insightful photos of your offices too.
Yes, all real, all real.
Have such a good humor. Guys, we still have time that we can do now the QA. Do you have any questions to David and Kurt? Anybody? Did you have your coffee? Before we will go to the lunch break.
There's a couple of, I think there's someone who wants to ask a question here.
I see. Wait a minute, mister. I'm coming to you. Excuse me.
Hello.
Hello.
My name is Orestes. I'm a DevOps engineer. And I would like to ask, how was the period from getting from the local data center to the cloud? How did you handle it? Did you have half traffic going to the cloud and half to the data center, or what?
Yeah, very, very good question. So the way it was during that migration is everything was still in the local data center in Malta, like we mentioned. And during the transition period, we had a couple of hours of downtime where we had to migrate the whole of the application, because running it in active-active, you need to make sure your database are in sync. It might introduce more problems than just solutions. So we opted for a maintenance window where we shifted the application over there. And we also shifted our traffic out from our CDN to the new data center.
Basically, the applications were set up prior to the migration date, right? And the data was already being synced. So the maintenance window Kurt is talking about was actually the very bare minimum time required to sync the delta, the lag behind in the data, make a couple of spot checks, make sure everything is up and running as it should, and then hard switch and remove the maintenance page onto the new Azure data center.
Thank you.
Anybody else who would like to ask some questions?
We have one here.
In the front.
I'm coming to you.
These are
Done,
two more
mister?
questions than I expected we were going to have, right?
Sir?
Thank you. Hi, my name is Theo.
Hi.
Regarding what you were saying about your migration, did you have a rollback plan?
Yeah, we did.
That's a funny story, actually.
We did, but you get to a point when if you're syncing your data and you need to cut it halfway, we kind of had a rollback plan, but we just decided to push forward.
At one point, there is no rollback plan you can do in such a big migration.
Yeah.
At some point, you have to just say, okay, I'm just fixing this forward.
And when you have like the data, the amounts of data that we have, just thinking about stopping that in between, having to switch back, you need to remember that there are DNS caches online, so you need to let that expire. It just introduces a lot of issues. We had it in mind, but like David said, we just said double down and push forward.
Sometimes you have to just go renegade and
Yeah.
do it.
Okay. Yeah, I know the feeling.
I'm sure you do.
Thank you. Anybody else? Any questions?
It's fine, guys. Don't rush. We have time.
I see that a lot of hungry people.
Yeah.
So, Kurt and David, are you from Athens? Are you from Greece?
We're from Malta.
Yes.
We're based in Malta. But we really, really love visiting Athens and all of your different islands. So we like to come here.
I love to hear that.
Sunny Athens. Yeah, so I think we're done, right?
Yeah. Thank you for joining us here today, guys. We'll be next to the Novibet booth if you guys have any other questions you would like to ask. But besides that, thank you very much for attending. Cheers.
Thank you.
Thank you.